let us discuss about gases. So gases have different properties such as volume, pressure, and temperature. These properties are related to each other, and their relationship is described by the different gas laws. Let's start with the volume and pressure. The relationship is described by the Boyle's law. According to this law, the volume of a gas is inversely proportional to the pressure exerted by the gas at constant temperature. So we can express this law into an equation that is this one. Again, here, the volume is inversely proportional to the pressure. So we have this one is the constant of proportionality because here pressure and volume are or they have proportional relationship. So make sure to watch those videos before going into this lesson. Now from this equation, we can derive this one. So here I just cross multiply this one. We have K is equal to pressure times volume. And on this case, since again the pressure times volume is constant, so we can say that again, the initial pressure and volume is equal to the final pressure times volume. So that is equal to this equation over here. So we can use the Boyle's law to predict the change also on the other variable if one variable is changed. So in this case, we have from 1 atmosphere, our pressure is increased by a factor of 2. So again, that's from 1 atmosphere naging 2 atmosphere. Now, what do you think will happen to the volume if the pressure is increased by a factor of 2? So again, on this case, we have they are inversely proportional to each other. So the inverse of 2 is 1/2. So in this case, our volume will decrease by a factor of 2. So it will be cut into half. That is from 22.4 into 11.2 liters. Now next, what do you think will happen to the volume if our pressure is changed from 1 atmosphere to 0.5 atmosphere? So that's by a factor of 1/2. Now, what do you think will happen to the volume? So the inverse of 1/2 is obviously 2. So in this case, our volume will be multiplied by 2. That is double. That is 44.8 liters. So again, that's the relationship of volume and pressure according to the Boyle's law. Now let's use this equation. Again, this is just equal to these equations over here. Now let's use this equation to solve this word problem. A 7.50 liter gas has a pressure of 0.750 atmospheres. Determine the volume after its pressure is increased to 1 atmosphere at constant temperature. Now, the first step again is to recognize the given. So again, we are going to use this formula. So we're going to find out the value of the initial pressure, then the initial volume, and also the final pressure, and then the final volume. Now, this one contains our initial pressure and volume, and make sure to be familiar with the different units because that's how you identify whether this number is a volume and this one is our pressure. So in this case, this one is our volume. We have 7.50 liters. And then this one is our initial pressure. We have 0.750 atmosphere. And then after that, we have the 1 atmosphere. This one is our pressure. We have 1.00 atmosphere. And then we are looking for the final volume. So that is question mark for now. Again, we're going to use this formula. So copy this equation. P1 times V1 is equal to P2 times V2. So we're going to substitute the givens on this equation. Our P1 is equal to 0.750 atmospheres times we have our our V1 is equal to 7.50 liters is equal to our P2 is equal to 1 atmosphere, and then we're looking for the V2. So again, we're looking for the V2 here. So what should we do? Divide both sides by 1.00 atm, 1.00 atm, then cancel. What's left on this side is the V2. So we're going to shift it here to make it simple for everyone. Then just solve this one. You can use your calculator for this. That is 0.750 times 7.50 divided by 1, that's the same, right? So we have here we have 3 sig figs on all of the givens. So let's round this one to 3 sig figs. We have 5.63. So 5.63, cancel ATM, what's left is the liters. So that's what we're looking here. So the volume is 5.63 liters. Let's proceed to the next law that is describing the relationship of volume and temperature. We have the Charles law. The volume of a gas is directly proportional to its absolute temperature in Kelvin. Now from this one we can get this formula. Again, the volume is directly proportional to its temperature. Again, here we have the constant of proportionality because this one has a proportional relationship. Then again, from this we can derive this formula, or we can have this one, or we can have this one. So let's go back to the relationship. So on this case, we have volume, then temperature. On this example, we have our temperature increased by a factor of 2. What do you think will happen to the volume? So since again, on this case, we have directly proportional relationship, so the volume also will increase by a factor of 2. So that's from 1 liter to 2 liters. So again here, if we double the temperature, the same thing will happen on the volume. Then on this case, we have from 20 Kelvin to 60 Kelvin. That's by a factor of 3. What do you think will happen to the volume? It will become 3 liters because again, the same will happen. The same thing will happen on the volume. So that's what we mean by directly proportional to each other. So let's use this formula over here to answer this problem. A 15.00 liter of a gas is collected at 45.0 degrees Celsius. What will be its volume upon cooling at 20.0 degrees Celsius? So again, first recognize the givens. We have V1, then V1, we have T1 is equal to V2 is equal to V2, then T2. So here we have the initial volume. Again, that's liters. We have 15.00 liters. Then we have degrees Celsius. This one is 45.0 degrees Celsius. Then our this is the new temperature, or the V2. We have 20.0 degrees Celsius. Then we are looking again for the volume. By the way, on this case, the temperature must be in Kelvin. So since this one is in degrees Celsius, convert this one to Kelvin. And how do we do that? So just add 273.15 from the given degrees Celsius. Again, plus 273.15. That's how you convert degrees Celsius into Kelvin. So again, that's 45. 45 plus 273.15, so we have 318.15. We have 318.15 Kelvin. Okay, 318.15. Then we have for this one we have 20.0. 20 plus 273.15. So we have 293.15. 293.15 Kelvin. Now we're ready to use the formula again. V1 times T2 is equal to V2 times T1. Our V1 is equal to 15 liters, 15.00 liters times our T2 is equal to 293.15 Kelvin is equal to V2. Again, we're looking for V2. Then for T1, we have 318.15 Kelvin. Again, we're looking for the volume. So divide both sides by this one, 318.15 Kelvin, 318.15 Kelvin. Cancel this one, what's left is V2. Then just solve this one, we have 15 times 15 times 15 times 293.15 divided by 318.15. So we have 13.821 something. So here we have 3 sig figs, then 4 sig figs. The lowest number is 3 sig figs, so let's round this one to 3 sig figs. We have 13.8. 13.8. Then cancel Kelvin. We have liters. So we have our V2 is equal to 13.8 liters. Let's proceed to the next law. We have the temperature and pressure. The relationship is described by the Gay-Lussac's law. So here, the pressure of a gas is directly proportional to its absolute temperature. So we have these formulas over here. We have P is equal to K times T, or P over T is equal to K, or we have these formulas over here. So on this case, our temperature increased by a factor of 2. Now, what do you think will happen to the pressure? This one is ATM, by the way. So again, here we have directly proportional. So this one is also changed by a factor of 2. So that is from 1 atmosphere to 2 atmosphere. Next, we have this one from 30 Kelvin to 90 Kelvin. We have times 3. The pressure will also increase by a factor of 3. We have 3 atmosphere. So that's the relationship of the temperature and pressure. So let's solve this one. A gas is heated from 75.0 degrees Celsius to 85.0 degrees Celsius, and the volume is kept constant. What is the final pressure if the initial pressure was 1.5 atmosphere? So here we have, again, let's use this equation over here. So first, identify the givens. We have P1 time P1 T1, then we have P2, then our T2. This is our initial pressure, and then this one is our initial temperature, because here we have from. So this is our initial pressure. We have P1 T1, we have P2, we have V2. Our initial temperature is 75.0 degrees Celsius. Then our final temperature is 85.0 degrees Celsius. And then here, what is the final pressure when the initial pressure is equal to 1.5 atmosphere? 1.5 atmosphere. So we can use this equation over here. We have P1 times T2 is equal to P2 times T1. Our P1 is equal to 1.5 atmosphere times our T2 is equal to 85. By the way, let's convert this one into Kelvin. So the same thing pa rin, the temperature must be converted to Kelvin if the given is in degrees Celsius. So we have 75 plus 273.15. So we have 348.15 Kelvin. Then this 85 plus 273.15, so we have 358.15. So let's go back again. Our T2 is equal to 358.15 is equal to, our P2 is missing, then our initial temperature is equal to 348.15 Kelvin. And again, we're looking for P2, so divide both sides by P2. Sorry, P2 by 348.15. 348.15 Kelvin. Then 348.15 Kelvin. So we have P2 is equal to, so let's solve this one. We have 1.5 times 358.15 divided by 348.15. So we have 1.54 something. So here we have 3 sig figs. No, we have 2 sig figs as the lowest. So 2 sig figs, we have 1.5. We have 1.5. Cancel Kelvin. What's left is the atmosphere. So our P2 is equal to 1.5 atmosphere.